Welcome to my video. In this video we're going to be looking at one of the searching algorithms for AQA's GCSE in computer science. The searching algorithm we're going to look at is the linear search. Before I explain what a linear search is, I want to just cover the basic concept of searching, or the word search. So let's just forget about computing for just a second, and I want you to imagine that you think you've lost your mobile phone in your bedroom. In order to find that mobile phone, or attempt to find that mobile phone, you would look in various locations in your bedroom. If you find it, it becomes found and you stop looking for it. If it wasn't in the bedroom in the first place, well, you'd search and then you'd get to a point where you would realise that it's not in the bedroom, so it would never be found in the bedroom. So that's the basic concept of searching, and it works exactly the same in searching algorithms. So let's take a look at the linear search. A linear search starts from the beginning of a data set. Each item is checked in turn to see if the item is the one that we in fact are looking for. Okay, so what's a data set? A data set is basically a collection of data. So for example, there's one here, okay? So I've got a collection of data here. Now this is a collection of numbers. Now it doesn't always have to be numbers. For example, I could have a collection of animal names, okay? And I could still search through those to identify if a particular animal name is within the list, okay? So what are the advantages and disadvantages of a linear search? A linear search doesn't require the data set to be in any particular order. It will work on any type of storage device. It can be very efficient on small data sets, and it also is very inefficient on large data sets. Let's just look at that in a little bit more depth. So here, I've brought up the one that says does not require the data set to be in order. So this one is in fact not in order. What do I mean by that? So for example, if it was in order, the number 2 would be at the front and 45 would be at the end. Okay, and all these would be in order from smallest to largest. Okay, so this is the green one. Now this one is in fact in order. So what I mean by that is that a linear search doesn't require the data to be in order to find the item. Now obviously if the data was in order, it would still work, okay? It just means that linear search can work with it not in order or in order, okay? But the big advantage that you need to remember for the exam is linear search's advantage is it will work on data sets that are not in order. Perfect. Okay. It's very efficient for small data sets. So here, look, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 items. So to find the number 9 in that wouldn't take long at all. It'd be fairly quick, which means it's efficient, okay? It's gone through and it's found it pretty quick, okay? Now, the main issue is that it's not very effective for large data sets. So imagine that you've got a factory, and inside of that factory you've got millions and millions and millions of products. So you are searching for a set of black football boots. Now imagine that you've got to go through every item in that factory one by one to check whether or not it matches the criteria of black football boots. That would take a lot of the time and be very inefficient. Okay then, linear search from start to finish. How does it work? So for this example we are searching for the number 9, okay? And I'm going to introduce this that I've just popped on the screen. These are called indexes, okay? Now indexing always starts at 0, okay, or should always start at 0. In some exam questions it may start at 1, okay? So in this example I've got 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, it may be 1, 2, 3, 4, 5, 6, 7, 8, 9. However, the correct way is the way I have it here. Okay, it should start at 0. But some questions in your exam may start the indexing at 1. Okay, but the correct way, okay, the way in which programs actually work, is we start an index at 0. So, if I was to say to you, what is at index 5, you would say 45. If I was to say what's at index 1, you would say 20. What's at index 8, you would say 11. And what's at index 0, you would say 13. Okay, so let's start then. So here, we are checking list index 0, okay, which is 13. And then we're saying 13 equals 9. If you don't know this, double equals means equal to. So this reads 13 is equal to 9, okay? And in fact we know that that is in fact false because 13 is not equal to 9, okay? So then we would want to increment through this list, okay, using a loop, okay? We could achieve that by doing this, I equals I plus 1. So this index here, I could take it, index, which is 0, 0 plus 1 would give me 1, so we would move to here, just like so, okay? We'd look at list item 1, or index 1, which is in fact 20. 20 is equal to 9. that is in fact false. We'd increment by adding 1 again, so 1 plus 1 would give us 2. Okay, so we look at this now. 17 is equal to 9. We know that that is in fact false, and we go again, keep incrementing. Okay, now imagine this was a large list. It would just keep going until it found it, or until it had gone for every item if it wasn't there. So 3, inside of 3 we've got 6. 6 is equal to 9, false. Inside of index 4 we've got 7. 7 is equal to 9, false. Inside of index 5 we've got 45. 45 is equal to 9, false. Inside of index 6 we have got 2. 2 is equal to 9, false. Inside of index 7 we have got 9. 9 is equal to 9. Okay, that is in fact true. So we have found the item and we know it is in fact inside of the list. Okay, and that's exactly how a linear search works. What I have done now is I have turned it into a flowchart, because in previous videos we've looked at flowcharts and pseudocode. So I want to show you how it works, because in the exam you might be asked to draw a flowchart for a linear search, or the pseudocode for a linear search. So this is going to help you with that. Okay, as said previously in other videos, flowcharts should always have a start and a finish. Okay, let's step through this. Now this time we're looking for 17. So I've set I to 0, so that was the index, or the incrementing, what I'm going to use to increment the loop I mentioned on the previous example. Now found is set to false. This is because before you start searching you haven't actually found what you're after. It's common sense, isn't it? So let's start then. So we've got to here, we've set I to 0, we've set found to false because we haven't found it yet, and now we're here, list I. So I is 0, so I pass in 0. So we go to here. Now here I would pop on my index numbers, wouldn't I? You might have to draw those on in the exam, okay, but I've popped them on for you. So at index 0 we have got 13. 13 is equal to what we're searching for, 17. Well, that's a no. So I equals I plus 1. Okay, so 0 plus 1 becomes 1, and we come back around the loop and we're back here. Okay, so now we're looking at index 1, which is 20. 20 is equal to 17. No. I equals I plus 1. So we do 1 plus 1 gives us 2. We come back around the loop. List item index 2. So we look at index 2 is 17. 17 is equal to 17. Well, that is actually true. So we go down the yes path, and found becomes true, and then we finish. And that's basically how the flowchart would work for a linear search. Let's take a look at the pseudocode. So the pseudocode here, I have placed some pseudocode here. I have placed a trace table here, and I've placed a list here. Now I've got this little red dot, okay? Now this is called a breakpoint, and what I'm doing is I am stepping through each line. I'm going through the code line by line, okay? I'm going through the pseudocode line by line to identify whether or not I need to update my trace table, okay? And I've just placed here item as well to help us out. Let's go through it then. So here I've got found is false, okay? I've put the indexes on again to help us out. I is 0, okay? And then we come down to here. While found is false. Well, found is false, and I is 0, so it's less than 9. So we come down to this if statement. So we're here. Okay. If item I, which is 0, okay, 13, hence why I've popped it there, is equal to find item. Okay, item to find, 17. 13 is not equal to 17, so we don't go inside the true, we come down to the else, okay, and we run I equals I plus 1. So 0 plus 1 becomes 1. Okay, and then we come back around the loop. Now, found is still false, and now I has been updated to 1. Okay, so 1 is still less than 9, so we come back down to the if statement, and we look inside of item 1, which is 20. Okay, 20 is equal to 17. Well, we know that's false, so we don't go inside of here. We go down to the else, and we go inside of here, and we increment to 2, and we come back around the loop again. So now we're here. Found is still false. And I is in fact 2 at this point. 2 is less than 9. That's true, it's still false. So we come down here. Okay. Now inside of 2 we've got 17. Okay. So 17 is equal to 17. Okay. Well then we go inside of the true. So found becomes true. Okay. Now we've found it. How does the program know to finish? So we come back round again then, and we come to here. Now this time, found has been set to true. It's no longer false. Okay. I is still less than 9, but this is an AND statement, so both of those would have to be true to trigger it. Okay. But this one here is no longer equal to false, it's equal to true. So the program, or the pseudocode, sorry, would know to terminate. finish. Okay. So, challenge for you. If you want to now, you can have a go at creating the actual real code for a linear search. You'll notice here that I have in fact blurred out the code because I've made it. Now what I've done here is I've got it using the example on the previous page here to basically step through till it finds it and it stops. Hence why 13 is equal to 17, false, 20 is equal to 17, false, 17 is equal to 17, true. So mine stops after it's found it. So the code, I have got it here but I've blurred it out. So what I'm going to say to you now is if you want to have a go, feel free. I am about to press next, which will show the answer. Okay, so pause now if you want to have a go yourself and then come back to my answer afterwards. So on the count of 3 I'm going to show my answer. 1, 2, 3. So that is the way in which I did it. Okay, so this is the most basic way you could do it. This works quite nicely. Copy it out, have a play with it, see what it does. Okay, if you feel like that's relatively easy and you want to challenge yourself, here I have got 1, 2, 3, 4, 5, 6, 7, 8, 9 items. Try adding some extra items and see what happens. Okay, and then search for something later on in the list. So for example, search for, I don't know, so add 22, 33 and 66 and then try searching for the 23 because you'll notice here that I'm going while I is less than 9. You might need to update that part there, but it's something for you to look at. Okay, so moving forward, okay, to recap, a linear search starts from the beginning of a data set. Each item is checked in turn to see if the item is the one that we are looking for. The advantages: it does not require the data set to be in order. It will work on any type of storage device. It can be very efficient for small data sets. It is very inefficient for large data sets, and that is to summarise what you need to know for your exam. Thank you for watching. I hope you enjoyed the video.